Okay, it looks like we're live. So welcome back. Today I'm going to be continuing to work on CanoScript. Alright, so today I would like to implement strings so that we can use them as variables and such. Because right now we have strings, but we can only use it for like a write syscall, and that's it. So I'd like to be able to define variables, be able to change it, things like that. And since we have arrays now, it's going to be easier to implement them from that. So let's see. So what I'd like it to look like. Let's get rid of some of this stuff. So something like this, right? So x stir equals string. Da, da. Okay. Yeah. So like something like this, I think that would be good. Right. So you can define a string, and then you can also index it. So you could set it equal to. I'm not going to implement character literals yet. So you just set it equal to this. That's actually like a new line. So you could set it equal to ASCII values. And then I'll implement characters later. I have to update the Alexa and things like that, so I don't feel like it yet. But even actually, I guess set it to like that. And then I guess that could work as well. I'll think about that. But things like that, right? So you could actually compare them and then also set it to the index of other strings, things like that, right? That would be nice to have, right? So, let's see. So it's going to start in the front end. So we need to add one thing to the Lexer, and that's going to be strings, right? So let me do token type. Do we have those in here? I guess those are defined in front end. Yeah, here we go. So let's see, where do we have token type? Actually, token type. Do we have token type? Yes, we do. Okay, so we need to do that. So we already have that. We just need to search for it. So let me search for where I have it. Yeah, so here's the data types. Just finished watching the video on CanoScript on YouTube. Not too far back in time. What are you going to do today? Today I'm going to be working on strings. Right, so I implemented arrays. That was a few days ago now. And today I'd like to implement strings so that, and then, we can use them as though they were arrays, right? So it's going to look like this, right? So you can define it like this, just using a string literal or whatever, and then I was waiting to implement this until after arrays because obviously you need to be able to index it to be able to change them, So things like that. But yeah, that's basically the plan for today. And it shouldn't be too difficult. Most of the stuff's in place now. How are you doing, by the way? Okay. String. Kind of like C string. Yeah, yeah. Well, I mean, most strings really work like that, right? Um, it's just there's some abstractions over it. Okay, where is? Actually, so do I have that? Yeah, so right here, token type, and then that. Okay, okay. So that's gonna be a string is that index, so that's gonna be 1. Alright, so I think that's good for the lexing, so we should be able to lex it now. Alright. Then, yeah, now we can move on to the actual parsing of it. So in here, it's not gonna be too much different actually. Actually, I do have to modify the type, so that is like the where we handle that. So we have type. Yeah, right here. So we have type stir now. I need to add it. I think we have that. Almost something work like that. And C is actually called a char array. Yeah. And you don't really have to think about it like that in other languages. So I see why you would say that. Makes sense to me. Data type side. What do I have data type side? This is the wrong file. Data count. That is there. Okay, so we need to increase it there. So the stir, since it's a character, that's 1 byte, right? So that is what we are going to assume in this case. When you're modifying it, you're going to be modifying it 1 byte at a time. Because yeah, it is a character array, like in C. Okay. So that is good. So now we should be able to actually parse it. So what do we have to do? So we encounter an ident, and then it's a colon. So we parse variable declaration. So how do we handle that exactly? That's up here. So actually, I think that is it. So this should already work to do that. We just need to add to the parse expression we need to handle strings as expressions, right? So there's not really, well, hang on, what is this? Why do I have this here? Okay, parse expression. So strings are going to be part of an expression, but it's not going to be valid to do like, you know, string plus 5, something like that. Like, that doesn't really make sense. So we need to account for that, you know, type check, right? Parse expr, we have the very hard to find the definite. Okay. So, in here, yeah. So parse, I actually want to go to parse primary. That's where we're at. All right. So if it's an integer, then we do this. If it's an ident, so we need to also have else if token type equals to each string. I forget if it's string or stir, but it doesn't matter very much. And then we're going to set it as that. So we need the value dot string. So we'll have to update the expr to have a type of string, and then the value dot string. So it's just gonna be like a string view. So we have the length of it and the data, right? So that's pretty much it for that. So I need to update the expr, which is defined in here. So expr, where's that at? I think it's expr type I have. Yeah. So that expr stir, and then the expr value is here. So we need string view string. I could just use variable here as well because it is a string view, but for naming purposes, it is easier to do this. And since it's a union, it's not like we are wasting space or something like that. Okay, so I think that's all. So we don't really we don't account for mismatch types, right? So I'll get to that after. I want to get it working though, like assuming it in this way, right? But I think that should be it. So then we just have to update the code generation, right? So when we gen expert, if we encounter a, oops, yeah, right here. If we encounter an expert string, we have to push the stir, right? Expert stir, push stir, state file, and then I think it's something like that. So we generate that, right? We have the string. That's gonna be all that we have to consider in this case. Right. Yeah, because that pushes the capacity of the string, and in the case of a string literal, the capacity is the same as the length. It pushes that, and then also the pointer to the beginning of the string. So we have that. Let me see if it compiles. It does actually compile. Did it? Yeah, okay, so it did properly compile. So something like this. Yeah, so then when we call write, we actually want to parse an expression rather than that, so that we could put a variable here, right? Because right now this isn't going to work because it is not the correct type. Like if whoops, I didn't need to make it actually main kno. Yeah, expected integer but found string. Wait, what is that? Oh shoot, actually, I think I expect the type of integer. Let's see. Yeah, so it was turning that to be an integer. So that's something I forgot to modify. So that's in the parser. Let's see, parse, and we encounter an identifier, and this is where we're doing that. So parse variable, which is right here. So where do I expect type? Okay, no, so it's not actually there. It is. It's gonna be the next thing after that. So we have an equal. Expect token equal, and then consume that. Else da append that parse expert. Okay, so parse expert. Search for parse expert. Whoops. I put a capital. Okay. So why did it expect a? Oh shoot, right here. Because I forgot. Token not type. Does not equal token type stir. I think it's string actually. Yeah, I forgot to add that. So we have to add that type. So I should probably make a function for that, so that I can just sort of like using variant arguments. But I can do that later. So now it should actually should fail at a different place. So like a string we found ident. Yes. So that is the thing. So when we have a write, let's see, right. We have that. Right now we're parsing native node. And let's see, what do we want to do here? Hello, how you doing? How you doing? What is up? Hmm. Yeah, so this is where it's at. So switch on the type. Uh-huh. I'll release comments. Yeah. So basically, a string is now part of this as well. So we really just need to parse the expression. Telling my type is not equal type string. And that. And do that. Yeah, because now the value is incorrect. I'm just going to comment it out because I don't want to get rid of it necessarily yet. Let's see. There's that. Okay. Now, yes, so we unexpected token none. That's interesting. Something failed there, but also there's no X, first of all. There's no Y. We need to actually handle it properly in the backend. So when we have native right. Yeah, so case native right. Yeah, so this is what it found. So yes, we really have that. We need to type check properly, but I will skip over it for now. And then we want to push stir, but really want to then expression state file mode value dot cards data 0 dot value dot expert. I think is what it is, right? Kind of a long thing, but then that would generate the push stir as well. So we don't need, no, we still need that. And then we call it. So that should work, right? We have to check to make sure it is a string, but other than that, yeah. So it's still saying unexpected token none. What is that from? Just want to make sure it did compile properly. Oh. Okay, yeah, so unexpected token none. That is interesting. So that's probably in the lexing. Maybe I could use GB and see where it's actually saying that. Okay, so where is it failing specifically? Okay, I thought it would jump us to the line, but it did not. So let's break on maybe then program again run. And do we get to that point? So we do not. So it is in the Lexer. So let's try to find out where. Expected token. Okay, so we get here. So must consume too many. So let's go to parse native node again. And then we consume a token and this. I think that. And then we parse the expression. Value.expert. Yeah, okay. We're setting that of the arg. And then we append it there. Native value. What is native? Native value is the integer that we pass. Okay. Yeah, we set that. And then we return the node. Okay, so I think that's fine. Parse name node. And then we append it there. Soon, do we not want to consume it in this case? Because it is handled differently. Yes, okay, so that was actually the issue. That makes sense. So basically, before we had to consume it because we're handling it differently, where we did not consume the string, but the parse expression does in fact do that. So now these are the same thing. So I need to I can back some stuff out there. But let's look at it when it actually generated. Okay, so this is not right. But why did that happen actually? It's an X. Well, it is a string, so that's the thing. So yeah, we don't have that. So I need to. That was probably it was trying to get the string, and the boundaries were not right. We push stir string, and let's see. Does it actually generate it properly? And try it out. Let's see. Run, and it outputs 1. Oh, and it does output string. Okay, let's add a new line here, and let's do that. Why is there a 1 though? I don't quite get that. it still like in here? No. Why are we outputting 1? We did output string though. I'm reading too much. No, had some. Induce 0. So that's gonna be that. It's gonna be the string. Yeah, but where is it doing that? Negative 1. Pop. So let me go through. So this pushes the length of the string, so we'll say 5. I'm not gonna count it right now. And then it pushes the stir, right? And then we duplicate 0, which is gonna be the stir, the pointer to it. Push 1, and then we call it, so it writes that. And then we pop off the stir, so it's not great. Watch how I work. Nice, nice. Is your work programming? I would assume so, but you know. Why do we pop? Because then that pops this off, and I don't necessarily want to do that. So I don't know why we do that, but I still don't get why it outputs 1. Let's see. Let me try yeah, it outputs 1. So that's kind of strange. I don't know what that's about. Python webhooks for lab management software. Nice, nice. Okay. So that's in the gen, right? Let's see. So native right. Why is it that? So native that. You know what? Actually, did I? Hang on. I'm gonna try something. So if I run this, just test. Try another variable. Y stir equals as. I do like that, right? Y. It's egg faults. Okay, so something's definitely not right. I think it might be overreaching, right? That's egg faults as well. So why? Alright, well, first of all, this is not right. It's trying. Oh shoot! I see what's happening. So it tries to grab from the wrong place. So the stack position is incorrect. The issue actually might be an expert. So if we go up to that, I think I know what it is. Let's actually do gen push stir, right? We call that. We push stir, and that actually increases the stack size by 2. So that is an issue. Yeah, because it pushes the capacity of it as well. Alright, then it actually outputs that. It still is saying that though. Yeah, because now this is right. So it considers it properly. So the stack position was correct, but the stack size was incorrect because we were only counting it pushing 1, essentially. I still don't get why it outputs 1 though. Where is that from? I don't know. Do I have a print statement in here from the native? What's up? Okay. I do. Okay, right here. That's what it is. Yeah, so it's just a print statement. I was debugging some stuff, and that is why that happened. If I rebuild all that, and now I run, it will not have the 1. I guess it does. What? Wait a minute. Let me rebuild. It might be cached. Okay, let's try that again. And it's broken. There we go. Now it's just not output. What's the goal today, by the way? I am trying to strings, right? So we don't have support for strings yet. Well, now we can declare variables like this. But I want to be able to declare variables and then index them, like as you would with an array, So, whoops. Basically, I want to be able to work with strings. That is the goal. And I got this working already. So we can declare strings as variables. We can write variables. So now it's going to fail if we try to write 15 or whatever, but we'll fix that. Yeah, that's basically the goal, is to do that. And then, then we can write functions to compare strings, and we can do cool stuff like that. Okay. Are these arrays of characters? Yeah. So like, I can show exactly how it works in the, yeah, it is like in C, because it really is C, like, um, under the hood, right? I can show, right, so, strings, I can show, so basically we have strings, and what we do is we push, the capacity of the string. So in the case of the string literal, the capacity is also the size, but there's times where that won't necessarily be true. And we also push the pointer to the beginning of a string, like it's just an array of characters, right? And we store it in the memory, you know, like how you would in C. So basically, it's the same as C. I would like to add some higher level things to it, so you can just get the length and things like that without having to, without the null termination characters. But currently, it does have the null termination characters, and it functions the same as C. Yeah, so pretty much. Okay. So, alright, so what is, it's gonna set fault, yeah, okay. I need to check that. So when you are using the right syscall, it needs to be, you generate the expression. It cannot be a, it has to be a string basically. So let me go to that. Okay, so that's sort of here. Alright, so yeah. Well, this shouldn't be an assert now. This should be a if that it's greater than 1, then we will print error like this. Do you write code at work as well as these hot practice? I do not have a job currently, so I do not write any code at work. I write code for school though. I am in school currently. But yeah, so I have a couple, like, they're not very big school projects. But I have some of those, and then most of it is just stuff that I stream, like hobby projects. Okay, so that doesn't work. Let me actually just get it. Okay. And exit. Okay, so I'll do that. And then with this. So we need to check the type, but it is not quite that simple. So expert. We need to check the expert type. I can't do that. Expert stir. That's not exactly gonna work. Okay, let's try that. Okay, we don't print the location yet, but that's okay. That value that. Expert is 8.8. Okay. Now it compiles and let's see. Space string. Okay, there we go. So that works. And shoot, actually that's not what I want. No, it could be a string or an identifier. Right. So really, maybe we should even check it in the gen expert. Okay, well let's try that. Maybe we'll set the expert. We'll make a variable for it, right? The type equals this. Data 0.value.expert type. Okay, there we go. And then we can just check type. And type does not equal expert. Okay, yeah, because we can handle either of those. Do we not have expert? Is it var? Did I call it that? Suppose I did. Okay. Alright, so that works then. So we can output that, and let me make sure I can output another one. So write y and then write x again. That should write string as string. Yes, okay, perfect. So we don't need this anymore. So we still need some more type checking in the actual expressions. Probably on the level of the parser, right? But let's see. Yeah, I'm not gonna do that yet. So I want to implement the features, and then I'll worry about type checking stuff after. Let me actually implement that. Stir variable. Okay. So we have that. Then we have most of it already. So let's see. Actually, it might already just work because it is. Well, no, we need to define it as an array when we encounter a string type. I forgot about that part. It's not considered an array now, and that is obviously gonna be problematic, right? Let's see. So parse. What are we parsing? It is var def. Yes, and then if it's that, so or it is a. Basically, want to set it equal to that. So var that is array equals token key. So we can do this first of all. Not type. So if there is a bracket, right? Oops, I spelled that wrong. Or node.var.type equals is it type stir? I think it's called. So either of those. So then it's going to be true or false, right? I think that works. Yeah. So I can show how it works. So we're generating. It's not really an assembly. So I can. There's sort of like a stack to it. There's 3 levels of it. So the highest level, right? That's what I'm working on. Is the scripting language. That is like this. So it's supposed to be like a higher level language. And then we have that compiles. This is just a temporary thing, but it compiles into an assembly, which isn't. It's not like a native assembly. It is an assembly for a virtual machine that I built. This is not right. Okay, that's a problem. I'll need to look at it. But it compiles into this, so it's not. It's like an assembly over which then that gets assembled into this bytecode here. So this is like the bytecode for the virtual machine. Yeah, so the virtual machine then takes the bytecode and then it reads it as a series of instructions, which then it executes to basically do stuff. With C as sort of the like the runtime, right? The runtime is written in C. So that's sort of just temporary. I want to just compile directly into the bytecode, but right now it's easier to debug and stuff using the compiling it into the assembly because I can actually read through it and see what it generates. But yeah, so it is into an assembly, but it's not a native assembly, if that makes any sense. I can explain further if that did not make sense, by the way. Okay. Ident. Okay, I see. So it doesn't want us to use this because it's expecting it to have a bracket because of how I coded it. So expected what? Where is it? So let's do use array. We do that. That's the variable declaration, but we want actually that's not right. Okay, I see. We're trying to generate it as an array. And so let's see. Variable declaration. Yeah, so we don't want to do it like that because it doesn't work like that. So if it is an array and the node.value.r.type is not equal type stir. Okay, so it still failed that where we are trying to grab it. So let's do is it in the chain expression? It might be in there. Is that VM open source, separate project? Or it is a project that I wrote, yes. That is this. So right now, this is the virtual machine. It's called Tim. Subject to change the name. But yeah, so then in here, there's a subdirectory called KanoScript, and that's where I'm writing it now. And then I'll move it into its own project once it is done. But yeah, it's all written by me. So this doesn't have any external dependencies, except for C standard library. Yeah. So this is entirely written by me, yes. Array. It's array, yeah. So here is that. Okay, it might actually be in the parsing. That makes sense. So this is where we do that. Where did I expect that to come from? Could be here. Yeah, that's probably where it is. Okay, so if it's an ident, and it is an array. Okay, so this is where it's at. So we're parsing it. No, this is actually fine. So it's not there, is it? Because it should be in here, actually, where we are parsing it from. So I can make sure that it is not for this one if I just change it to as the right before that, and I can see if it changed. Okay, so it is in here. So for some reason we are parsing that. Why is that? Let's get rid of some of those. It shouldn't be doing that. That's right here. Now it's failing in. Wait. Expected that, but found right. Okay, so we're actually reading past it. I see what's happening. So, let's see. It's again the parse expression. Let's go up here actually. Parse primary. Let's go to that. Okay, and then it's a func call. If it is an open bracket, then it's an array. We don't have that. Whoops. Where is that? Okay, so we generate. Not exactly sure. So, kind of right. So why is it trying to read that far? Parse bar. Okay, let's look at that. Did I mess this up? Let's see, we don't enter input here, right? I want to make sure that it is not, for some reason, reading that. It is not. Okay. We do make it to this point, so I just want to make sure that. Actually, let me print out the node value dot as array, right? As a bool. Just like that. That's fine. Node value var is array. Alright, just want to make sure that is set to true. And it is indeed. Okay, so that's fine. So we don't need this in here. Parse var that. So that's here. Oh, okay, so I see what's happening. So we're sending it there, and then we're doing this. So, so the problem is, it can't be a string in this case. So when we're parsing an array, we need to set it as an array, but we don't want to parse it as though it was an array, because can I ask more questions? Yeah, you can go ahead. Ask a question. Ask any questions you need to. Totally fine. I can focus and then move on to something else and then come back to focusing. It's not too difficult. So, dot type is not equal type stir. Okay, let's try that. Then we did output string. All right, that is good. Now we should be able to actually index it. So if we do this equals 11. So if I send it to that, there we go. It did actually insert an ASCII character there. How much wood would a woodchuck chuck if a woodchuck could chuck wood? A woodchuck would chuck as much wood as a woodchuck could if a woodchuck could chuck wood. Okay. Yeah, so we can actually set it. We can only set it to integers right now. But let's see. So what is, I think 64 is A, right? Oh, it's a. What is nice? I don't remember all the ASCII values. S-fring, but yeah, we can modify it, as you can see here. So I should be able to actually say, make another one. So it equals, let's see, string 2, right? Then we could set, well, we can set this equal to, y5, right? That's gonna be, G, so it's gonna set T to G, if it all works properly. There we go, it did actually send it to G, that's pretty cool. Okay. And I think we can compare them as well. So if if that equals that, then let's actually do ones that aren't the same. Then we'll write x. Otherwise, we will not write anything. Let's try that. Okay, wrote x, and then if I change it to not equal, it should not write x. Okay, there we go. Implicit int conversion. Yeah. Well, because the char is really just an integer. What? How many instructions are there? There's quite a few instructions. Let's see. So some of them are not used, but basically there's this many instructions. So however many this is. That is, so it's 52 minus 1, because this is not an actual instruction, it's just for the count. So there's 51 instructions, and some of them are not currently used. Like, let's see, so there's a specific one that I was not using, I don't remember. Yes, like getStir and dupStir, those are from something that I was testing out that I decided to remove, and I haven't removed them yet. So there's a few. So there's probably somewhere around like 45, maybe a little bit more than that. That many instructions. Okay. So let's see. Plus plus on a string index. Well, there is no plus plus currently, so that's not a thing already, but yeah, I mean, yeah, thank you for following, by the way. Okay. Yeah, it might change in the future. Right now, I definitely want it to be like that. But yeah, in the future, right, so once I actually implement support for character literals and things like that, I might remove that, because you don't necessarily want that. For now, it's fine, and it's not like a big deal. There's a lot of unsafe things you can do currently. But yeah. Okay. So that works. Let's see. So, okay. So I could also make a loop, right? So while let's make it an I. So I equals 0. I does not equal. It's not equal. We don't have the character literal. So what? It's 0, right? I don't know if that's good. So what is not that? Yeah. So I really need character literals, but I equals I plus 1. So let's iterate it, and that should be the length of it. So with I. Second word. Couldn't integer but found colon. So where is that? 4. I don't know what that means. Is I should be reserved for something. Okay, I don't know what that is about. It's like integer but found colon. Let's see where that's at. Affected integer. Actually. Do we have somewhere where we expect that? Alright, so that's probably in the parts primary then. Is that what it is? I change it. So, is it something to do with I? But what is it? Selected int or ident, but found if. Okay, that is definitely not right. Okay, so this actually. Is it reading that as if? Ooh. I guess when it's if? That could be a big problem. I think that would go. So I need to figure that out, but that should be 7, right? Yeah, so it's 7. So that did work. And if I change it to the y, then it's 8. Okay, yeah, so that works. But so why is I if? That is not good. Definitely a big problem. Let's see. So it's in here if. I see. So right, if this is success, so if I put E, that'll be the same problem, right? It will consider exit. Yes. Okay. So that is not good. Yeah. So it's to do with this. Okay. So what I might want to do actually is I'll get to. I'm gonna make it a string view, right? Let's just pass the word. Search for. Alright, so that's the only use. So let's make it a string view. Stir, and then this can be view compare. And then we need to actually do view for this. Actually, that's gonna get kind of ugly looking. So let me make a string view. Right. So this is the well, okay, it can't really just be a string view. Okay. Yeah, let's do this way. So we'll use that, and then yeah, okay, that's fine. So I don't really like that, but I just want to make sure it works like this, and then I can change it to an array of. We can just compare on each element of the array, right? Hi Bob. Hi Bob. How you doing, Bob? Okay. It's actually kind of not good. Good, good. Glad to hear. Alright, let me just still compile it. Well, okay, it's not gonna entirely compile because of these. Let me make sure it's not complaining about that. Yeah, okay. So that's okay. Six. Alright, last one. I think it's actually not gonna work because of okay. It's a different data type, so I need to cast it. So not cast it, but create from it. And so what we want to do is we create word with data and word document. Okay, then now compile it. That's not let's make and store the compile is not right. It be view compare. And same here. Okay. Else without a please. Alright, so I'm messing it up somewhere. What is this? Where's that at? What? 53. If don't want to equal 0 though. And we have too many, no, wait, that's right. Hang on. The bracket. Oh, wait. The bracket. Mhm. After right. Oh, shoot, I see. Okay, thank you. Yeah, okay. My bad. I see. I see, I see. Wait, there's something else. Wait, what was it? Something else wrong. Hang on. Previous declaration. Oh, yes, I need to change the header file. Okay. Okay, that compiles it. It should work. So now, let's see. Expected insert. Okay, that's not good. Huh. Okay. Yeah. Go back to that. Um, this breaks down. Uh, types. Look at that. So what type is it? If. So they're all if now. Oh shoot. Yeah, because I forgot to get rid of all the equal zero. Because this one works where it returns true if it is true. Oops. Okay. There you go. Now it should actually work. Okay. Yeah, now it prints all those out. Yep. Okay. Fine. And I get rid of that. Okay. 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 And there we go. Prints out 8, which is the length of the string. So if I increase it to that, it's going to print out the length. Or not print, but it will echo the length. Okay. Very cool. So I should be able to use I for this now. Yes. Okay, now it is not thinking it is if. That is good. So let me. That was actually a big problem, and I'm surprised I've not encountered it yet. Let's see. Fix issue where the string compare with group types. Did not work. Is that the best way to explain it? Sure. Yeah. Okay. Very cool. Very cool. Square bracket moments. Yeah. Okay. So let me test it, right? So we can index it and we can compare that. Actually, let me introduce character liberals. Commit in the present tense. Yeah, I used to do it um in the past tense, but then I've changed my ways. I don't think like does it necessarily matter that much though. I don't know. Okay. Yeah, so character literals, that's just in the lexing, and then we need another type of character. So, alright, I'm going to implement that, but I am going to take a quick break for about 3 minutes, and I'll be right back. And then, yeah, character literals. Okay, I am back, and wait, it does have the knowledge right here. Okay, yeah, but that is right. The down notch. We mean it should be right here. It just depends on the font, right? Okay, I guess. Okay, it doesn't matter. I could see I could read it as that though. That's kind of fun. I didn't even think about that. Um, so we need to lex it as a string. So we need token type character. We do have the escape. So these are the only escape characters that are supported. We do need. Yes, we have that. So that's fine. To add the new token type. Token type. Let's see. What do we have string? We need token type char. Speak char literal actually. And the string should be string literal as well, but I'll change that later. Okay. So, basically we need to parse it the same as a string, or lex it rather, except one character, right? Unless there's the escape, but where is the, it's right here. Okay, so let's start by copying this and go from there. So, that it can stay the same, and chop left, so that chops off the opening, the opening one. I actually fix it. The opening quote, right? And then do this. It's not that. And then we can encounter a slash. Then what is this? We append to that, and then okay. We check the escape. Right. So really this makes it look like strings. I don't really want that. So that. Okay. Char. Should be char or just char link. Do that. So the token value is gonna be that. So can I trying to think. So what do I want to do for that? Building VM. Is that what we're using now for the script part? Yes. So I built the VM, that was a few months ago. I made the assembly to test the virtual machine, right? The bytecode and stuff. And that is now what I'm using to compile it into. Yes. I made some decisions while making it that I don't necessarily like now and need to sort of be refactored. But yeah, so that is it indeed. So let's also do we got not we got but we got like greater than 2. So if it is greater than 2, that means it was an improper escape character, right? So we can print an error. Let's use this way. Error characters cannot be made up of multiple characters. So I guess that's just how it happened. Something like that. And then so I don't really want a string view though. Okay. You think so? Basically, that will create. I guess that's fine. right? Because it's going to be the same size, so that must be okay. So we need a string. Okay, and then I would like, so what was I trying to do? I'm going to be able to do something like this. So we need to consider that in the expression, right? So we need parts expression. Do we have to? Yeah. So parts expression could be a do I really have? Hang on, let me think. So I need to think. So how do I want to? Yeah. So let's do this. Character below. Then expert char. Then we'll set so we'll have a string value. Is that? Yes, that's fine. But then when we push it, we're gonna push it as a character. Because it's kind of hard to convert it to a single character when you have escape. You know, when you have that, it's treated as two characters. And then we can convert it in the actual assembly, at least for now. We'll push the single character value. It's kind of hard to explain. We need to add that, so qd expert. Expert type. Yeah. That's what I call it. It's char, okay. That's fine, because that actually makes sense. Okay, and it's still using the string, so that's fine. And then in the, well, let me make sure that it will push it properly. Alright, so we need to add that to the switch. Type string. I just want to add it to this switch statement. Children type char. Okay. And then else without a previous if. Did I mess this up? Seem to have. How? This is not right. All right, that was the issue. Yeah, put the quote before the backslash. Slot lane is count. Okay, 32. All right, let's try running this thing. So it should all right, expected type, but found integer. I'm not sure if that is what that is for. It's here. Expected type. We have that. Alright, so we don't have type. So that is be somewhere else. So let me run through GD and make sure it's failing at the generation stage, right? So let's break on gen program. Okay, so it is not. Expect. All right, let's see where it would be. So let's see. Expected type if an integer. Why does it do that? Did I do something wrong? Oh, it's probably in the parse binary, right? Yeah, add some printing. Let's see. So we go through that a few times. Mm, where do I expect that? Here. That's it. Okay. So it's first fail. That's it. In here. Okay. That's one. That's two. And look at that. No, so it's not even in there. Huh. Type of an integer. It's in the wall while loop. See, I want to kind of narrow down where it would be. Okay, so it is in here. In the parse expansion. So yeah, okay, so it's from this one. Oh shoot, I see. Token type is not equal token type. Sorry, literal. I forgot to add that again. Okay. Unreachable. Oh. In the back this time. Yes, we don't handle it, that's why. Yeah, because you don't have case expert char late, right? Then push. Except we're not pushing a we wanna push a character. So push go with a character. Okay, so let's do that. So we'll make a new one, gen push. It's still gonna use the push instruction, but it's for character specific. Push character. And it's gonna take a string. It's gonna push it like this. So that okay. Just the value, but you are value. And I can look at what it generates. Mm, 7. Yeah, it's just X with a char. Then, assuming if I'll do, because I forgot to break out. Okay, and let's run that. And if you look at the assembly, it should have, yeah, push this. So it pushed that, and that's gonna compare that. Okay, so we can do that then. And you echo that, and it works all the same, except we actually have a character literal. So it should be able to also set X, let's set, let's see, I don't want to do that. Let's get rid of this, and let's get rid of this as well. So we'll write X and write Y, and we can compare them, right? So let's set let's do this X. We'll set X to equal to A. Let's set it to a tab actually, that should be interesting. Yeah, so it did actually create the tab right in between. So you can see the difference. That's a large tab. I don't want it so much. Okay. I was trying to do it so we could make it A. Yeah, so there we go. So now we have actual character literal. So I might make it so you can't use you know, yeah, it will not implicitly convert to this, right? But I'm not gonna run that now. Not yet. Okay, so there we go. That is pretty cool. So let's see. Yes, we can make a strlen function. We can make a string compare function as well. So maybe I will make some of that. So let's try string compare, and it's gonna take xster and or maybe a xster and b xster, right? And we'll return an integer. Okay. I also need to make a void type so that we can have return void. But anyway, so we'll do well mm, well x I with bi. Okay. And we'll make I int equals 0. I equals I plus 1. And so while we do that, and then if let's see, what do I want to do? So if xi equals that, we don't have and or, so we can't do that. Then we don't really have a way to break. Yeah, we don't have and, so we have to do like this. If b, we don't have brackets though, or parentheses. Yeah, I equals that. Then return 1. Return 0. Okay, something like that. It's a bit messy because of reasons, but let's see. I might have wrote it wrong. I still write them though, but I don't call the functions. That's the problem. Let's get rid of this stuff. And we will call third compare x and y. It's actually an x with that. I think that should work. 0. Okay, so they're not the same. But by make them the same then. Let's get rid of the new line. So it's like that. And there we go. Very straight. They're not the same. Okay, so it did not work. So I might have actually messed something up. So wait, while that. You can also do this, because basically just adds to it, so it's gonna do that one. Okay, so we can't really do that. Right, x. What about I at reference before assignment? Why is that? Right text. So it's not write that a second time. So that's not good. Why is there an extra space as well? Right. It does not even call this. Okay. Let's actually right. It doesn't call that at all. Oh shoot, no, it's just kind of ran it again. 2 and then I'll just recompile it anyway. Okay, so yeah, that's the point. If that's why it does that. So let me swap green swap. Okay, so then that will sort of put it back how it was. And, okay, it's still doing that. So maybe that doesn't work. He's calling the function though, but I just overloaded that. I want to take a look at this, what this is. So the first one, well actually I'm going to do it first. Which actually get negative 1. So that will print out what the value of this is, which should be string. String, okay, that is right. So I don't get why it skips over that. Which one? So this is, yeah, that's the index in the string. Why is it 1? Why does the index start at 1? Huh. Not good. So with A, oh, okay. I think this to return what does it call that? Yes, okay, so it's always just skipping to the end. Alright, so it does work like that. So it starts, at the start they're not equal. Huh. Yeah, so I don't get why there's 1 here. New 5 and new 1. Do push 1 and negative 1 so we can write what that means. So it's straight. That's right. Huh. Get what the issue is now. For instance, that's going to be the character that's on the top of the stack. Which is X. Okay, that's right, that's the first character. Uh-huh. We don't compare them though. Oh, but we compare these two. Okay. Let's think both of these. S and S, so that is right. As in they are different though. This one's still the pointer, is it? Oh shoot, that could be it. Huh. So we're comparing with the pointer. Why is that? Right, because then this must fail, right? Yeah, okay. I see. Yeah, so this is gonna be 0. Whoops, wait, what? Did I not say? Yeah, I guess I did. Yeah, it is 0. So that's they're failing because they're not the same. So why is there the pointer on the top? Noob 1. That should push the character. And then, oh shoot, it's because we noob twice. So why are we doing that? Doing a double on the offset. Um, offset, so that's one down here. Why does it generate twice? Oh shoot, because we generate the expression, so... Huh. So do we not need to do that? Hang on, let's see, so I need to think about this. So, what is 1? Let me print that out. It is a... It's a nil pointer, what? That should be the index. Oh shoot, yeah, because we're adding to the pointer, so that's what we're doing. Uh-huh. A new one, so that's this value here. Okay, that makes sense. Yeah, obviously. And then push 1, so Yeah, we multiply it by that because that's the size of the character. Let me add to the pointer, cast it away pointer, and then push 1 and read because that's how many bytes we're reading from it. So that's right. But why do we have the extra pointer on the top of the stack? So there's still the nil. But yeah, so we have the character on the top of the stack here, right? That's what, yeah, that's what it was. So then we do this, and we do the same thing. So this is still the same thing. It's just we have extra stuff on the stack now. So do 2, so that is the string. And then, yeah. And this is the variable after. And, oh, shoot, but we're pushing 8. Uh-huh. So that's the wrong type. So that's why this fails. Yeah, we want this to be push 1. Like how it is here. So why is it different? Hint chain expression. So type is that. If we type. Oops, I didn't exit that. Is that? Okay. Alright, type is where'd it go? Shoot, I'm in the wrong file. That's what the issue is. Okay. Then expression. Yes. Right here. That's what I wanted. Okay. So yeah, I want to see what the type output is. One zero 1 0. Okay. So why is it ever that? So it's something wrong with this. It's making it incorrectly. That is not good. So why does it think that this is not a string? It's an integer. So check expression. Let's see. Get the actual thing. Okay, here we go. And so I can print out the type. And also I can print out the name as well. Expert array name. That's not what the value is it? XB. Oh shoot, because I'm using X here. I want to use A. Yeah, okay. So that is a problem. Ooh, but it sees them as arrays in a different way. It actually return one though. And then it returns, okay. Same. We'll try it. So same. Let's try that. It's 1. And then, alright, so I do see there is an issue, so I need to look at that, but same. And, okay. Very different. Okay, so that worked. So I was using X in there instead of that. But the issue is, it's still not the right thing. Yeah, because now we're pushing 8, so it does not see it as the correct type. So why is the type that? Oh shoot, because on the function deck, right? We do this. Name equals that. And we don't set the type. I do that. There we go. And now it sees it as a string type. It should still output the same thing. There we go. Okay, yeah. And then if I do make this X instead of A, it should still work. So it's like accessing a global variable, but it should still work because they are the same. And it does work. Okay, there we go. So now it sees it as the proper type. Before it was seeing it as an array of integers. Which is not exactly correct. So that's fair point. Okay. Yeah. I see. Makes sense. Right. Yes. Thank you for that. Yeah. So obviously, what would be ideal here is like an and, right? We do not have yet. And I'm not necessarily there, but you know. Yeah, okay, so that actually is alright. That's alright. It should work. So okay, very cool. Also, we could just pass it like this. Why did that? That's seg fault. Okay. Why did that seg fault? So it would be assembly then. So it's probably something we call it. Okay, I see what it is. Because we're not expecting it to... Well, no, because I guess we account for that. So why does it do that? Call string compare. Where is... Alright, string compare right here. So we push 0. Dupe 2. So 0 would be the top. That would be this one. 1 would be that. Okay, I see what it is. So we don't increase the stack size enough. In here. Yeah, okay. Because right here we do that. But if we're pushing 2 things, then we need to account for that. So, right. Stack size needs to increase depending on the variable type. So how do I want to, because it's not always if it's a string. Because it could be a string as a, but I guess if it's an identifier, then that's different anyway. No, because this is always identifier. So hang on. Right, Alright, that's gonna be a 2D, so 2D. Because I do have to go about now. Does not push the buffer stack size when using stir variables. So the solution would probably be to set it so if it is a string, like whether it's a string identifier or a string variable or a string literal, we want to double the stack size and we want to actually grab the length of the string as well, or the capacity of it rather, when we call the function. So that is what we need to do, but I'm not doing it yet, so it's a to do. So it's not going to work for the time being with string literals like this. We have to use variables. Yes. Okay. The cool thing now though is I think we should have enough. Whoops, put that back. Should have enough stuff to actually convert an integer, or convert an integer to a string. Just like write a function for that, and then we can call that and actually print out numbers. So we can make cooler stuff with that. So that is something there. But I do have to go now, so I will connect this. Let's see. Actually, what's the difference? Is there anything? Okay. I change. I don't think I actually changed anything. I think I was just writing code, right? Did do that. Okay, so I don't know what it was. So I should not have called it. I don't know. That's fine. I'll look at the diff in here and then make a follow-up command. Push character. I do not have that in here. Okay, so I renamed the command. Alright, whatever. It's fine. It's fine. Okay, so I guess I added that. So I thought I committed that before. I guess not. Okay. Yeah, I'll worry about that later. Yes, that is gonna be about it for today. So thank you for watching, and I'll see you guys next time. Bye.